The tidal generator generates electricity from the rise and fall of the tide. The working model shown here consists of a watertight hollow tank with a sealed wall around the perimeter of the top surface. At the top is a blue wheel representing an electrical generator which has a drive shaft connected to a water turbine. A sealed pipe passes through the tank from top to bottom. The tank is anchored to the seabed by cables attached to the bottom of the tank. The water turbine is installed in the pipe. It is powered by water passing to and from the open sea into the wall area of the machine. Here, the tidal generator is installed in a test container. The pink balls indicate the water level in the open sea, the blue ones indicate the level in the walled area. Now, the tide starts to come in, as shown by the pink balls rising. The pipe through the tank is closed at the moment by a valve, so no water passes into the walled area and the blue balls do not rise. A clumsy attempt at opening the valve using the lever on the front of the tank shows how the tank is floating under the water. When the valve finally opens, water flows from the open sea into the walled area, indicated by the blue balls rising, driving the water turbine and electrical generator. This continues with the levels in the open sea and the wall area rising, with sea level always being ahead until the tide is fully in. At this point, the water level is the same in the open sea and in the walled area of the tidal generator. Then the tide starts to go out, as indicated by the pink balls starting to fall. The higher water level in the walled area is supported by the buoyancy of the hollow tank. When there is a suitable head of water, the valve is opened and the water flows from the walled area into the open sea through the pipe driving the turbine and electrical generator. Now we see the whole thing happening again. The tide is just starting to rise, as we see the pink balls rising. Now the valve has been opened and the water is now again passing from the open sea through the pipe and electrical generator, turbine and electrical generator, and we see the blue balls rising and the pink balls continuing to rise, with the pink balls, which is the open sea level, always being ahead. Now the tide is just about fully in, with the level inside the walled area and in the open sea being the same. Here the tide is now going out again, with the water level in the open sea now being less than the level inside the walled area. So the water flows from the walled area into the open sea through the pipe, driving the water turbine and the electrical generator. The additional weight of the water inside the walled area is supported by the buoyancy of the hollow tank. In the real world, in a machine like this, 100 yards square and with a tidal range of 20 feet, 50,000 tons of water would flow through the turbine every 6 hours. With a tank perhaps 4 feet high, capable of supporting 3 feet of water, this could generate about 20 kilowatts at the most favourable phase of the tide.